Hello and welcome. Today, we're diving right into the heart of the semiconductor fab to look at how artificial intelligence is becoming the ultimate co-pilot for lithography engineers. Let's get right into it.
So just imagine this for a second. You walk into the clean room on a Monday, but instead of some blaring, unexpected alarm, you get a simple notification. Your EUV scanner has been analyzing itself and, well, it predicts a component is going to fail in about 7 days. Oh, and it's already scheduled the maintenance and ordered the part.
And look, that's not science fiction. It's not some far-off dream. It is happening right now. This is the new world of intelligent lithography, where the most advanced hardware on the planet is being paired with some of the most advanced AI. To really get how big of a deal this is, let's first step into the world that you, the lithography engineer, live in every single day.
Let's just set the stage. Your job, it's a high-stakes, high-pressure environment unlike pretty much anything else on Earth. The margin for error, it's literally atomic.
You're working with tools that are just monumental feats of engineering. A single, top-of-the-line EUV lithography machine can cost up to $200 million. I mean, that's more than a Boeing 737.
And what are you doing with this incredible machine? You're printing features down at the 3-nanometer scale and even smaller. That's about the width of 6 silicon atoms. It's insane. You are working at the absolute bleeding edge of physics.
All that pressure comes from the fact that if one of these machines goes down when you're not expecting it, the cost isn't just a few $1,000s. No, it's millions of dollars for every single day it's offline. That is a crippling expense and a massive, massive headache.
So how in the world do you manage that kind of pressure? Well, you get a new co-pilot. And let's be crystal clear about this. AI is not here to replace your expertise. It's here to augment it, to be your partner in the fab that spots patterns, sifts through data, and predicts problems before they even happen.
This right here captures a huge strategic pivot that's happening. The game is no longer just about building more precise hardware, it's about creating intelligent systems. We're seeing it with huge players like ASML investing heavily in AI. The whole industry is shifting from just making equipment better to making it fundamentally smarter.
Okay, so this AI co-pilot sounds great, but what does it actually do? How does it solve the real-world, everyday problems that keep you up at night? Let's get specific.
Let's start with a big one, downtime. The old way, it's all reactive. An alarm goes off and it's a mad scramble to figure out what's wrong, all while the clock is ticking and millions of dollars are just vanishing. The new way is proactive. AI gives you true predictive maintenance, turning all that chaos into a calm, controlled, scheduled event.
So how does it actually work? Well, there's an AI agent that's constantly monitoring thousands of real-time sensor streams from the Litho tool. We're talking vibration, temperature, plasma energy, the whole shebang. It's been trained on mountains of data, so it knows how to spot the tiny, subtle signs that are invisible to a human but are a dead giveaway that a failure is coming. So before the component even breaks, the AI is already scheduled to fix.
And the impact? The numbers are just staggering. As you can see here, bringing in AI-driven predictive maintenance can slash unexpected downtime by up to 50%. That is a huge boost to your overall equipment effectiveness, your OEE, and it's a massive weight off your shoulders. Now, predictive maintenance is one piece of the puzzle. The next giant challenge is yield. As this chart shows, yield loss, the number of bad chips on a wafer, can be responsible for 20 to 30% of your total production costs. That is a massive drain on profitability. For decades, yield management has been about detecting defects after they've already happened, and then you try to hunt down the cause. AI completely flips that script. It analyzes data not just from your litho tool, but from across the entire fab, etch, deposition, metrology, and it finds these complex connections a human never could. So you shift from detecting defects to predicting and preventing them before a single wafer is ever compromised.
And the bottom line here? AI-powered predictive yield management can cut that yield detraction by up to 30%. That's not just a little efficiency gain, that is a direct and massive boost to the company's revenue.
But AI isn't just working silently in the background. It's also fundamentally changing how you, the engineer, interact with these incredibly complex machines. And that dramatically reduces your cognitive load.
A key idea here is the digital twin. The best way to think of it is as the ultimate sandbox. It's a perfect virtual replica of your physical machine, constantly being updated with real-time data. It lets you experiment and analyze without ever touching the actual multi-million-dollar hardware.
And the applications are just so powerful. Want to test a new process recipe?
Simulate it on the digital twin first. Need to validate a software update? Run it virtually. You can accelerate R&D cycles and even train new engineers on a perfect simulation, all without risking a single production wafer.
Now, this is where it gets really exciting. Thanks to generative AI, interacting with your tool is becoming as simple as just having a conversation. Instead of digging through mountains of data logs, you can literally just ask your machine in plain English for a complex analysis, just like the one you see here. The system gets it, and it gives you the answer.
So let's bring it all together. What does this new toolkit actually mean for you? What's the bottom line on how all this transforms your daily work?
This table just sums it up perfectly. Every major challenge you face now has a powerful AI capability to tackle it, with a measurable, proven impact. Unexpected downtime? Predictive modeling cuts it by up to 50%. Yield loss? Large-scale data analysis reduces it by up to 30%. Those long R&D cycles? Shortened by 20 to 30% with AI simulation. And the skill gap? That natural language interface can cut training time for new operators in half. These are game changers.
So the key takeaway is this. AI isn't about making the engineer obsolete. It's about getting rid of the tedious, the reactive, the overwhelming parts of the job. It's about augmenting your intuition and your expertise, freeing you up to focus on the high-level, strategic challenges that really drive innovation. Look, AI won't replace a great lithography engineer, but an engineer who uses AI as a co-pilot will absolutely replace one who doesn't. This new toolkit is creating the super engineer, and the only question left is, are you ready to be one?